So I'm very enthusiastic, very excited to introduce Brendan Lee. I've known him for some time now. It's such a pleasure to have you here, Brendan. Thanks for sharing your knowledge with us. So your presentation is quite long and your introduction is long, but I'll try to make it as brief as possible. Brendan Lee is an expert and experienced in Bitcoin, member of Tokenized, and he knows a lot about the technical aspects, about the ledger. He's very adaptable and he can work under a lot of pressure indeed. He's graduated from Queensland University in Australia. Is that right? Yes. Okay. So I will actually not read all your introduction, all your bio, but Brendan, because Brendan's resume is really, really long and interesting. As a teacher, on the one hand, with teaching a lot of activities. So it's just a luxury to have him here with us. So I will just give the floor to him so that he can talk to us. He can introduce us in a concept that will be quite interesting indeed. It might be revolutionary right now, but I think it will become much more widespread in the following months or years. So that's it. Brendan, you have the floor.
Thank you very much, Ramon. So thank you very much for having me here today. So the talk I'm going to do is a little bit, I'm just going to talk a little bit about Bitcoin first, and then a little bit about Elast and how our technology works. I'm going to go reasonably slowly. And so Ramon, do you want me to stop periodically so you can translate, or is that happening live and I don't hear it?
The translation is simultaneous, so don't worry, you can just continue speaking and we can listen to you in Spanish. And you have your voice in Spanish is really nice as well, so go ahead.
So you just want me to talk or talk and stop? Okay, all right. So let me just share my screen here. Okay, so I want to talk today about Bitcoin, and it's one of my favorite things. I have been working in Bitcoin for over 3 years now. I cannot see myself doing anything else for quite a while at this point. It is one of the most interesting systems I've ever come across. And one of the things I would like to do is just to talk about the title of the white paper. And I think
Brendan, sorry, I'm interrupting you, but
that's all right.
So in order for the interpreter to be able to translate you,
okay,
I'm gonna ask you to get into your bottom menu inside the Zoom, click on the interpretation icon.
Okay, hang on.
And change the language to English. And so you'll be speaking in English and we'll be hearing you in Spanish.
Okay, interpretation, click Spanish. How's that? Oh, English, okay. I hit English.
Okay, let's see. Brendan, can you hear us? We are the translators.
Yes, I can hear you.
Great. So go ahead, we'll translate simultaneously. And go ahead, you have the floor,
great. So
you can continue.
Okay, wonderful. Thank you so much. So let me just jump back and restart sharing my screen again. What happened? Did I lose my... No, it's the Zoom. I've lost... I have too many things open here. Righto. Okay. Apologies for this.
No, tranquilo.
No worries at all. I already granted you the
Okay.
permission to share. That's it. Great, great. Now we can see it.
Okay, wonderful. So I wanted to talk a little bit about the title of the white paper and in particular the word electronic, because I believe this shows very conclusively that from the beginning of when Satoshi was imagining the system in his head, that he realized straight away that this was much more than just a software system. So it's more like a system of nodes who together perform a very, very specific set of duties. And they do this among each other, working almost as a team, but also in competition with each other. And so they're always trying to be better at this job than the other nodes in the system, but they're also working very closely with the other nodes in this system to make sure that the data is being shared properly. And I've done a few other talks about how the incentive structure of Bitcoin is actually designed for to promote openness and honesty between these central players who actually manage the network for us. So it's important to understand that the network is not just the same software running on as many computers as possible, but a multitude of different software, all operating in parallel around the whole world. And, you know, electronic voices talking with, over and around each other all the time, and coming to agreement on the ledger. And so electronic in this case, I believe, can actually be taken to mean anything from the supply of electricity and the management of electricity supply. You know, so there's right up to user interface specification. So using mobile phones, devices, new interfaces that we haven't even imagined yet. All of that is part of Bitcoin and will become part of the user experience as we drive forward. So yeah, it really is about efficiency. And so if one of the things I find amazing about this system is that it doesn't really matter what part of power, software, electronics engineering you come from, there is work for you in Bitcoin. And that's going to become more and more apparent as the years go by, and this becomes a very big industry. And I think it will be a great place to have leadership positions in electronics, in electricity management, and in efficiency. Because if you are the most efficient and most open node participating in the network, that's a very, very good way to become the most effective and the best and most profitable in the system. And so for me, it's really about infrastructure. So I take a step back from that. I don't participate in the process of running a node or being part of that consensus network that we rely on, but I use their infrastructure. And so it's important to understand who's or where the role of infrastructure is in Bitcoin. And I think Satoshi knew at the beginning that Bitcoin was never going to be about lots and lots of tiny computers, but it was always going to come down to very large data centers competing with each other to run the network. And this quote, I think, which is on the bottom of the screen, the more burden it is to run a node, the fewer nodes there will be. Those few nodes will be big server farms. The rest will be client nodes or client computers that only do transactions and don't generate. And so that's where we are. We create systems that operate on these client nodes. They only deal with a very small subset of the overall Bitcoin ledger. They allow the user to carry Bitcoin in their pocket without having to carry around an entire blockchain. And it's, so when you're thinking about what you're doing in Bitcoin and how your work is being used in the network, think of it in that respect. Are you in the process of helping consensus, or are you just a user? And can you step back from that whole aspect of the system and not worry about it? Because the nodes are the infrastructure that we depend on, but also they should be almost invisible to us. So when I like to think of the role of a node, it is to make using the Bitcoin ledger almost transparent. I shouldn't need to worry about what they're doing at all. I should just be able to throw transactions, data, information at the ledger and have it stick, and be able to come back at any time and see what I wrote. And so with this type of paradigm in service delivery, we get some pretty amazing opportunities arising. And so I want you to think about the possibility of a service that charges 1 cent for a service. And now the difference here is that you don't need to get the same user coming back 200 times and spending a 1 cent service, because you have to charge them $2, because it's not cost effective for you to charge them 1 cent, because now we have a system where 1 cent is a cost effective business model. If you can design a 1 cent service and find 1 million users each week, all of a sudden you have a $10,000 a week business. And so you can build an entire company around these massive volumes of very, very small value transactions. And you can have a relationship with hundreds of thousands or millions of separate individuals. And this is something that simply isn't possible today. And so once you can start thinking about, well, all of these new ideas, these new ways of approaching the market, of actually offering people things that improve their lives and deliver value, it really is a very open field. There's so much room to come in and build amazing services. And so I'm really looking forward to seeing what people start doing with this technology over the next, couple of decades, because we have a long way to go. And one thing that we can also do with Bitcoin is that we can actually tokenize it. And we're going to get a little bit more into that as I start talking about Elast. But this allows us to take Bitcoin and to exchange it as other forms of value. And so think of it like cash. So cash, physical cash, what we're actually giving each other is little pieces of paper. But we regard those little pieces of paper with a different level of respect, because they have certain attributes. They are a particular color, they look a certain way, and through that, we know that a government authority has stamped them with a secondary layer of value. And so we can also do that with Bitcoin. And so in that, thinking on that further, what is value? And so I actually wrote this when the crypto market was shooting up, and because I know when that happens, pretty much all of the conversations turn to the price of Bitcoin. I don't like talking about price at all. I think it completely is a distraction from the actual real work of getting Bitcoin services in the hands of as many people possible. But just to ask the question, what is value? And to me, I say the value is in the usefulness of the system, the usefulness of the network. So if I can earn 1 cent instantly from anybody anywhere in the world and keep 98 cents or 0.98 cents of that, that's hugely valuable. And there really isn't another system anywhere in the world where I can do that on any great level. I do that for 100,000 or 1 million people a day. And so when you start thinking about that, you actually start one thing I love about Bitcoin is that seeing transactions come in, that money landing so fast, so when somebody transfers you money, it really is instant. It is great fun. And I highly encourage everybody to try doing it. Big things are possible. So some of the things that we've been doing with our protocol is testing the limits of how many things we can create in a single transaction. We haven't yet done 100,000, but we're targeting that very soon in a single transaction. And we can generate very, very detailed webs of data, just like what we have on the internet today, except wholly owned and controlled and managed by the people who put it there. And that's what the MetaNet is all about. We're not really going to get into that today. But for anyone who is looking to get into the web side of things, I highly recommend that you start to learn and understand as much as you can about the MetaNet and how the MetaNet protocol works, because that is going to be a critical piece of infrastructure in that industry over the next 5 to 10 years. So for the second part of the presentation, I just wanted to give everybody a bit of an overview about Elast. And so this is the company, this is the other job I do outside of the Bitcoin Association, and what we do. And the easiest way for me to sort of describe an Elast ledger is that it is a fenced region on the Bitcoin ledger within which all of your activity takes place. And we build that fence by controlling which coins we use and in what way. And so we are always picking up and using coins that are already part of our ledger. And by doing it that way, we keep this very clear boundary between our activity and activity that's just happening out in the world. And so what we can do within a MetaNet structure, so that what the MetaNet allows us to do is build trees of data. And so within these kind of tree structures, we can create very, very detailed information and data graphs. And so if you're a corporation, you could imagine that you have nodes that are in there for your customer records to track your assets, for the files that you're presenting to people when they visit your website, all of these kinds of things. And have that stored on the ledger in such a way that there's no way that anybody can grab one of those items and not be able to confirm within a few milliseconds that it is 100% part of your ledger. It is the data item that you told them to go and look at. It has the correct information in it. And that's something that is not the case today with the internet. You can go to a website that you think is a real website and be presented with fake information. And it's a challenge for us today, but it's something that we can solve. So to go through the process a little bit more of how we actually create a ledger, it's very, very simple. We just say that we're going to create a ledger, and we perform a transaction into which we put some public keys. We might actually put a contract into that action, and that contract will have the details of the entity who is operating that ledger, the key identities within that entity. So say, for example, if I was creating an Elast test ledger, I would put my own name, the name of the other directors of my company. I would put some information about what we are using the ledger for. And if it's just a test ledger, I would just put, this is a test ledger. And we can store that information, pardon me, just jump forward a bit there. We can store that information as plain text, as JSON, as a HTML file, as an encrypted PDF, or even completely off chain. So we never actually publish that data into the ledger, but we publish a hash of that information. And so anybody who did want to know about this token ledger could come to us, ask for the hash, and if they have the right to see, if we determine that there's somebody that we want to share that information with, we can give them the exact contract that was used to create this ledger, and they can check very, very simply and cost effectively that this is the same contract that was used to create this node. And this is all stuff that we've been able to do for many years, except the storage in public side, which is only possible now with fully scaled Bitcoin SV. Once we have our ledger, it's then very simple for us to create subledgers. And so within that company subledger, we simply create a metanet structure under which each department of the company has its own ledger. And within each of those ledger, that part of the company can issue its own tokens. They can create subledgers underneath those subledgers. And so you can create this increasingly deep set of information and authorization paths. And it's very extensible. So you can simply keep adding more and more subledgers. It's very interesting. People get very worried about, oh, because it's permanent, nothing can be fixed. But I can tell you everything can be fixed. And it's merely a proposition now of having to do that fix in public. So when information is written onto the ledger that's not correct, it's about coming forward, making a record of that information being incorrect, and then taking the steps necessary to remedy the situation. And so we've already had instances where we have created hundreds of tokens, and those tokens have not been correctly issued. And so we have to recall those tokens. And it's not a huge amount of work. It can be done very quickly and very cheaply. And so despite things being permanent, it does not mean they are irreparable. And so once we have our subledger structure and we know what tokens we're going to create and where we're going to put them, the act of creating those tokens is as simple as taking a chunk of Bitcoin, and it doesn't even necessarily have to be a big chunk of Bitcoin. You can issue several thousand tokens. It is the data item that you told them to go and look at. It has the correct information in it. And that's something that is not the case today with the internet. You can go to a website that you think is a real website and be presented with fake information. And it's a challenge for us today, but it's something that we can solve. So to go through the process a little bit more of how we actually create a ledger, it's very, very simple. We just say that we're going to create a ledger, and we perform a transaction into which we put some public keys. We might actually put a contract into that action, and that contract will have the details of the entity who is operating that ledger, the key identities within that entity. So say, for example, if I was creating an Elast test ledger, I would put my own name, the name of the other directors of my company, I would put some information about what we are using the ledger for. And if it's just a test ledger, I would just put, this is a test ledger. And we can store that information, pardon me, just jumped forward a bit there. We can store that information as plain text, as JSON, as a HTML file, as an encrypted PDF, or even completely off chain. So we never actually publish that data into the ledger, but we publish a hash of that information. And so anybody who did want to know about this token ledger could come to us, ask for the hash, and if they have the right to see, if we determine that there's somebody that we want to share that information with, we can give them the exact contract that was used to create this ledger, and they can check very, very simply and cost effectively that this is the same contract that was used to create this node. And this is all stuff that we've been able to do for many years, except the storage in public side, which is only possible now with fully scaled Bitcoin SV. Once we have our ledger, it's then very simple for us to create subledgers. And so within that company subledger, we simply create a metanet structure under which each department of the company has its own ledger. And within each of those ledger, that part of the company can issue its own tokens. They can create subledgers underneath those subledgers. And so you can create this increasingly deep set of information and authorization paths. And it's very extensible. So you can simply keep adding more and more subledgers. It's very interesting. People get very worried about, oh, because it's permanent, nothing can be fixed. But I can tell you everything can be fixed. And it's merely a proposition now of having to do that fix in public. So when information is written onto the ledger that's not correct, it's about coming forward, making a record of that information being incorrect, and then taking the steps necessary to remedy the situation. And so we've already had instances where we have created hundreds of tokens, and those tokens have not been correctly issued. And so we have to recall those tokens. And it's not a huge amount of work. It can be done very quickly and very cheaply. And so despite things being permanent, it does not mean they are irreparable. And so once we have our subledger structure and we know what tokens we're going to create and where we're going to put them, the act of creating those tokens is as simple as taking a chunk of Bitcoin, and it doesn't even necessarily have to be a big chunk of Bitcoin. You can issue several thousand tokens with around $10. So you take a small chunk of Bitcoin and we chop it up into the tiniest possible pieces. And onto each of those pieces, we write information about what that token is. So you can see on this slide, we have token 1, token 2, token 3, etc. Each token has in this case, a value, a serial number, a picture, but the reality is we can embed any kind of information that we like into these tokens. And in fact, we can create these tokens with any kind of scripting process and a requirement for very, very specific solutions to be provided thanks to the Genesis upgrade and our ability to now use the fully unencumbered Bitcoin script. And we have some tokens that we're working on right now, which do use some quite specific scripting language to answer some very specific questions right in the script. And it's very interesting to see how that gets processed. And I very much look forward to showing people this in more detail. So these tokens can be issued as fungible tokens. They can be non-fungible tokens. Any kind of thing that you would like to do in Bitcoin, any kind of token that you want to create, this system can be used to generate those tokens. And so then when we transact tokens, what typically happens is we take the UTXOs that are in a particular output that we know holds a token. So in this example, token 1 would be sitting in the first token output of this transaction. When we spend that token, we take all of the Satoshis that are in that output and we transfer them to a new output. And when that happens, the system that's watching what's happening within that token ledger considers that that token has been transferred to a new controlling script. Now, that doesn't necessarily have to mean a new owner, but it just means that that token has gone through a new iteration and the conditions to use that token again have changed. And so it's not necessarily all about transferring value or exchanging money or things like that. These tokens can perform any kind of task that having a unique digital object that only you control can perform. And so that can be access to physical locations or digital repositories of information. That can be the right to participate in a civil process. That can be the right to travel or the right to, access content, anything like that. So there is an enormous possibility to extend this system across many aspects of our digital lives. I wanted to just cover quickly, before I try and finish up here, how we look at our token history. And that is something that comes up a fair bit. And I think one of the things that's a bit unique about the way we've approached the problem is that we actually do have multiple different ways of reading our token history off the ledger. And so the first is what we call a ledger scan technique, which is where the person who receives the token actually reads the previous transaction that the token is coming from and finds which output it came from. It then goes to the corresponding input in that transaction because we know that that's the same token, and it checks where that one came from. And it jumps back and back and back all the way until it finds a transaction where we can see the token is in an output, but there's no input for that token. And we then say, well, this is the transaction where that token is created. Once we get to that transaction, we look at the minting record that's in that transaction and we make sure that that transaction is part of the correct Elast ledger and it has been minted in accordance with the rules of that Elast ledger. So it has the correct signatures and all of that kind of thing. We've already tested this. It does work, but it's very slow. And so we have a couple of other ways. One is that we actually pass token Merkle-proof data between devices as we transact. This is something that we definitely want to implement in future, but it's not yet ready. The way we are doing things currently, and a way that we find actually does work very well, and it gives the users a quasi-instantaneous experience, is to store the token history in a state database. And so each time the token is transacted, we update the state database until we have, and so at all times that we have a complete record of that token's transfer history. And so anybody who comes and makes a request into that state database about what a particular token is can straight away have information about that token's denomination, the picture it carries, whether it's still considered valid under the protocol, and all of these sorts of things. And That is, now it's important to know that you don't necessarily need to trust any particular state database because the ledgers operate in public. It's possible for multiple different people to run these state databases, and even to run state databases that only look at a particular subset of coins within any given ledger. So if you had a huge ledger that had, potentially tens of billions or hundreds of billions of individual digital objects within it, it would be impractical for every small system that runs that to have that complete state database. But we can do a subset of that, and it's still a perfectly valid way of operating. And it's just that if a token does come into the system, the smaller part of the system that you're monitoring, you have to, that state database has to go back to the ledger and get its history so that it can validly handle that token. What we're really trying to do here with all of these different ways of validating that information is to confirm always for the user that they are in the correct place, that the tokens that they're handling are real, genuine tokens from that issuer. So the last thing we want is for somebody to be given like a cash bill and to find that that is a counterfeit, an item of counterfeit money. And we can make that exceptionally difficult to achieve. And so we do actually have tokens that we can demonstrate to people. So if you do want some tokens, please do reach out. We have some pretty nifty little non-fungible collectible tokens. So I know that a lot of people got them when we were handing them out at CoinGeek. We do still have some. So I don't have time, unfortunately, to stay around and hand them out to everyone after the talk. But please do reach out to me on social media or the other members of the team, and we can get those to you if you are interested, just to play around and see how those tokens function. But I think I've spoken for long enough. I wanted to see if there was any question and answer at the end of that.
Bueno, primero agradecerte, está buenísima
First of all, I would really like to thank you. Your presentation was great, and I was lucky enough to be present in many of your trainings. And what I love the most of listening to you is that you're really very didactic with a lot of like educational context. You know that very complex technical knowledge, you managed to make it understandable for everyone. So I do thank you for that. Now, questions. One question that they are posing here in the chat box and that I had in mind as well is the capacities that you can give to a token. For example, you can merge them, you can freeze them, you can split them. Could you explain a bit more, let's say, what would be the proposal of the Elast protocol?
Well, so it really depends on the end goals of the system, and we're talking to multiple different potential customers about different types of tokens, and what we're finding is that often at the outset we'll start talking to somebody and they'll say, "Oh, I want a token that does this particular thing." And we'll look at that and go, "Oh, well, that's very similar to this other token that we spoke to somebody else about. And let's pull this out and start to use it as an example." And then, but within the particular details of what that customer actually needs, we'll discover that there's a few core differences. And what it means is that we actually have to program that token in a very different way to what we thought was something very similar. And I think, so what I think is important to make known is that really we have not imposed any limits on on the people who use our tokens as to what they can do with them. Our protocol, if you like to call, I don't really think of it as a protocol, but the means by which we create our tokens is just a means by which to create tokens. And so it is the data that you embed into those tokens when you create them that defines how they will be used. And so if I was to give you an example of a token that is to be used as a replacement for physical cash, I would give that token, every single token, a serial number. I would have a picture so that everybody's wallet can display those banknotes to the wallet user in exactly the same way. I would have a denomination for each bill. So this one is $5, this one is $1. But that is completely contextual to the use case. So if I'm going to print a token now that's a non-fungible collectible card, well, maybe I do have a few that are the same, but realistically, they're not going to be used together in a transaction like fungible money. You're only ever going to be using one of any particular collectible card in any given transaction. So I would, maybe it even has some very similar information in it. So it's got a picture, it has a serial number, it has a type, but it's completely, the use case is completely different to these other bills that we created in exactly the same way, and which have, you know, if you put a Venn diagram of the different pieces of data, they share about 90% of the same DNA, but they're totally different use cases. And so for us, it's the product is very, very much about empowering the issuer to take the application and the use case that they have imagined that they can provide for their users and enabling them to build that. And so for that reason, we don't have any real rules at this stage. You know, I'm sure my team is tearing their hair out hearing me say this, because it does make things a little bit more complicated for us. But it's very important for our customers to not be restricted by any so-called rules that we might place upon them. Really, the only rules that they should ever encounter are the rules of the Bitcoin protocol. And so I hope that explains the question, because I didn't really answer the question at all. But you know, that's why I can't really answer that question. It's because the question, it's really, it's whatever you need.
Creo que
Yes, indeed. It's, as you said, enabling processes that such an abstract system, or let's say an asset abstract system, can create. A follow-up system or an idea identification system. So indeed, I agree with what you're saying, that use cases can be so different. So the more abstract the processes are, the more powerful, shall we say, or the greater capacity they can have. So another question in the chat box, something related to what you said. If not, I will continue posing my own questions, but no. Once the token was created, could it have different security measures for different units of the same token? They give me an example here. If I want to ensure my token with my personal keys, but someone else wants to use a multi-signature scheme, 2 or 3 parties, and we both want to own the same token, is that possible?
Absolutely. And so again, our token protocol, once we create the token, that token exists as a digital object, and the object itself is represented by the Satoshis that are inside the script. Now, if I transfer those Satoshis into a new script, it is the Satoshis alone that represent the token. And so I can put them into any kind of script that I like. And so if I want to take my Pokemon Gold Star card and put it into an account that I share with my brother and my cousin, so that we all three can use that card or whatever we want to do, I can do that. And for us at Elast, our token protocol does not care what that script looks like. So we can put a token straight into well, this is probably, if you don't know what optx is, it'll be a little bit hard to explain. But there's a type of script that we have that's almost like a forward-looking script, and it allows us to impose a future condition on a coin, and that's controlled by the script. And so we can take an Elast token that's been printed into a very normal script, but we can then spend it into what's called an optx transaction. And so that's a transaction that has this forward-looking script. And so we've now taken that token and we've put it into a process by which the user must manipulate it in a very specific set of actions in order to release it from that script. And that's not something that we control through the issuance process of our tokens, except to say, let us know what script you need the tokens to be printed into. And when you give us the list of scripts, that's where we put the tokens. And so the whole idea is that the token itself is not defined by the script that it lives in. It can then be used with any kind of script.
Perfecto.
Great. Another question. In the case you mentioned, this idea of the database, that database, would it be a centralized database? That is to say, would it be controlled by, let's say, an entity? And would it need the clearance or the authorization of the final user of that database? Would you need the authorization of the owner in order to transfer your tokens? I think the question, if I can interpret it, let me try. I think it's kind of like bringing the idea of an oracle, if it's helpful somehow.
Sure. And yes, absolutely. That's something that we can do. And so what we can actually create is, and so one of the things that we're working on is what we call a token register. And a register is basically a super wallet where there are more than one party involved in controlling any given token. And so when I would spend a token into a register, at that point, there is another third party who is now required to open the script so that I can manipulate that token. And so as an issuer, you can set the rule that states, well, these tokens must always live in a script where we are a counter signatory, because we want to control where they go and how they're used. And so that's a 100% a function of the use case. And we can enable that quite simply by printing the tokens out into multi-signature scripts where the issuer is co-signatory and is required to countersign. And what happens then is that whenever anybody wants to use the token, they have to present it back to the issuer, and its new state must also be a script of the same type where the issuer is counter-signatory. Otherwise, the issuer just won't sign the transaction, and you can't complete that next state transition. And so again, it's really completely up to the user. But so we can do a system where the issuer has to participate as a third party, but it's not a rule of the system. It's just something that's available as an option.
Claro, está habilitada la posibilidad.
Yes, yeah, exactly. Like an opportunity available. Great. Another question. If the Satoshis that are my object, my asset, if they get mixed with with other Satoshis, am I losing my token then? Do I lose my token?
So that's one thing that we decided very early on, is that the system does allow a user who uses the tokens incorrectly to destroy the tokens. And so if I gave you a $100 bill and that was sitting on 10 Satoshis, and you mistakenly picked up those 10 Satoshis and spent them into a transaction to pay for something with Bitcoin, effectively you have taken that $100 bill and destroyed it. And as the issuer, if I've given you that, if that bill has been issued as a cash instrument and we don't have a register where we're actively watching you and controlling how you use that token, that is a risk. And for us, I took the decision to allow this to happen, to allow tokens to be misused and destroyed, in order to enable us to take a step back and actually to push responsibility down onto the user, and to say this system only functions if you're a good actor. And so if I send you all this money and you try and send it out to a wallet that doesn't know how to use it, it's pretty likely that you'll break your stuff. Now, the good thing is, if you do break some stuff, I, as the issuer, can straight away see that you broke it. And when you come to me all of a sudden and say, oh, I lost all my $100 bills, I can say, yes, I can see where you did that. If we can get the Satoshis back, and we can reissue those tokens and we can give them back, and we can fix the problem. And so it's not the end of the world. And I think people need to start thinking of this relationship between issuer and user as being a little bit more symbiotic, and in that we can be, let's say, pragmatic in the way that we handle things. There is room for things to go wrong and then to be repaired.
Entiendo que hay dos conceptos por ahí que se...
I understand there are two concepts that also have to do with personal responsibility, right? And another idea is this possibility of auditing. And I have another question. I have a personal question that I need to ask, which is, what is the responsibility in the misuse of the token, where if I am capable of destroying a token that is associated to a wrong behavior, except that it's destroyed, I mean, in the views of whoever is auditing and this entity that is issuing it. So where does the responsibility lies? Who has the responsibility of that happening?
Well, it really depends on the system. And so if you are, so say for instance, we have a cash currency that's running using this system, and you have a business and you receive payments that come in the form of these tokens. Well, the responsibility for auditing your receipts and your business and reporting that is up to you. Now, at the same time, everything is happening on a public ledger. So for the first time, we do have a situation where the issuer of that currency can actually see with a great degree of detail how it's being used. And I don't mean that they can see that Huge is giving Ramon $5 for a cake that he just baked. they can't see any of that kind of information, but what they can see is that $5 was exchanged. And what that will enable them to see is that, well, okay, in this economy that we've created where we have 100 billion separate, unique financial instruments that are out there being used by people in the economy, is that the lower value coins, the 1 cent, the 2 cent, the 5 cents, we've had this huge explosion in microservices, and those coins are being used 10 times as much as the other coins. And what we actually have is a shortage of small change in the economy, and it's impacting the ability of the people who are building these microservices from getting money, because their customers don't have small coins in order to use the service. And so we, as the issuer, can remedy this by making more of those smaller denomination coins. And we might do that by pulling some larger denominations out of circulation, so that we don't increase the overall money supply. Or if we're not necessarily so worried about that, we'll just print more coins to have them being used by the people in the economy. And so there are multiple levels of audit. You as the issuer can audit at a very high level how many transactions are happening, which are the tokens that are being used the most, all of this kind of stuff, without necessarily having any connection or knowledge of the token users or what they're doing specifically with those tokens. Now, if I want to be much more in control and I want to know all of those details, I would put those tokens into a register, and I would require that anybody who wanted to use those tokens be logged in to a user interface where I have the details of who they are. And so once I've got that system set up, I can very closely manage exactly what everyone's doing. And when I audit my system at the end, I've even got the details of who did exactly what. And so again, it's very much about how you as the issuer want to use your system, how much control, how much audit do you need. So because if I'm the issuer of a cash currency, I don't have to hand an audit of my currency up to somebody else. I'm the one in charge. But if I'm using that in my business, I have to audit my own activity and provide that potentially to not necessarily the issuer, but some other third party who audits my business on behalf of the issuer. And so it's about making that as simple as possible as well. So.
Perfecto. Tengo la última pregunta porque sé que lo estamos extendiendo.
Perfect. This is the last question. I know we're going way over our time.
That's right.
Is it possible to, I mean, is it possible, for example, to create specific actions for a token that are different to just sending or receiving? For example, if a token would represent my right to vote in a board, for example, could it have the behavior of voting?
Está buena, a mí me gusta
Absolutely.
la pregunta, es una
I
implementación.
like the question. It's a very specific implementation.
Look, this is something that I have had my head into for a couple of weeks now. And I don't want to say too much, but what I can say is that we have an example of that exact use case that we're going to present very soon. And I think it's really going to change people's understanding of exactly what you can do with the Bitcoin. So, and in terms of how the script functions and how, and I'm using, finger quotes here, the exchange of a token can actually mean something very different to just handing somebody some money. We can actually embed a requirement into a script that before you can use that token, you have to formulate an answer that is a valid response to the question that's posed. And you can put the question right inside the token. And so the person can see what the question is. And if they don't supply correct answers, it won't let them spend. So I won't say any more than that, but that's something that we are working on. We have a very simple implementation of that that we are working very hard to release and just to demonstrate what's possible. So yes, absolutely, voting is something that I see as an area where we can shine a great deal of light on processes and on the counting process and all of this kind of thing. You know, it's and I think we have a lot to add to this conversation. And although today, so far, our voice is still very quiet in the global scheme of things, it will not be long before people can hear what we're saying. And as we demonstrate more and more the capabilities of the system to actually present people with information and selection options in ways that really haven't been imagined before, is really going to open people's minds up to the possibilities. So I won't say any more than that, but I really do look forward to showing you what we are working on, because it's me doing it and I can't believe how cool it is and how simple it's going to make this feel for people. And the level of confidence it's going to be able to give them in the way these processes are managed, because it is so transparent and so straightforward. So, yeah.
Wow, si yo lo abstraigo, lo que me estás diciendo es que hay...
If I have to take something from what you just said, is that there's a context with a variable that conditions a behavior, and that you can execute it in a token. And I say, wow, that is amazing. Thank you for answering all our questions, and thank you for, and thanks to the audience for asking them. I know you've made a big effort. I know you've been up since very early. I know in Australia it's very, very early. So thank you again. Thank you for your presentation. It was unbelievable, amazing. And I loved also the Elast topic. I think that this in the BSV community is in vogue. Everybody wants to understand the possibilities of the tokens and everything. We all want one of those mugs as well. And we thank you very much for your time and for taking the time to explain it, and to explain it so clearly.
Well, thank you very much, Huge. I really appreciate the opportunity to join you here today, and I hope that everyone in the audience got something out of the talk. And yeah, look forward to hearing from anyone who's got any other questions. You know, feel free to get in touch with me on the handle Elast Digital on Twitter, or yeah, I'm around. Huge can put you in touch with me if you have some very important questions to ask. Thank you very much.
Yo quería hacerle una pequeña pregunta.
Can I ask you a very short question before I say goodbye? I know
Sure.
it's taken very long, but there were images that were published, I think, at the time of the last contest that we had online. That was, well, in between New York and London. And we started seeing images on Twitter of Elast with different images. And the question about the tokenization process that was taking place. So my question is, these types of images, these types of tokens, were the type of collectible token, as they are sometimes referred to, because of the image that they had inscribed in them?
Yeah, so basically the tokens that we created for the CoinGeek conference were just created by us to serve as something of a demonstration of the capability of the system. And each token has its own serial number. They have a picture so we don't repeat the picture in every single token. We put the picture in a separate transaction, and then we link back to that transaction from all of the tokens that share the same image. And so for the tokens that we were handing out in the CoinGeek, we had 20 different types of tokens. We had 5 limited editions, and there were only 25 each of those ones, and those are all gone. And then we had 125 each of the more kind of like regular type tokens. And so we simply picked events that we thought were important in the history of Bitcoin, and created images. Like those images that are in those are simply created by us using Paint. Like we didn't use any kind of sophisticated software. We kept the images very small. So the image that you see in the browser that looks about this big, that's the full resolution image that we've stored on chain. And they're just there to serve as a very, very simple example of how the tokens can function. And so that to show that we can send you a small amount of Satoshis, and that you can have a wallet that can see those Satoshis, go back and look at the history of those Satoshis and determine that they are a valid token with, you know, a particular set of properties. And that includes a serial number, the picture, and all of that sort of thing. And that when you receive that in your wallet, that you can see all of that information correctly. And you know, in terms of a demonstration, that's about as simple as we thought we could get in the amount of time that we had, and just to make something that was, while being very simple, still quite a powerful example of what the technology can do. And you know, we're very excited to use or to create, you know, very similar tokens, but, you know, with real customers, rather than just doing it for ourselves to hand out. And yeah, it's all about how the tokens are issued, and it's at the moment of issuance that you actually embed all of that data that gets carried forward. Now, again, I want to be clear, that's only for that particular type of token. You can have a type of token where every time it's moved, it's got some data, a picture or something, and we can change that. We can update it every time we move the token. Now, you can't do that for that particular type of token. That would break that particular type of token. But if you have an implementation that needs a new picture every time you transact that token, well, that's possible too. There's no rules here.
Wow. En fin, esto se queda muy corto para todo lo que
This really, I mean, I would stay here talking about these things forever. It's really such an encompassing field, and it's like we're just getting started, I feel. In BSV, we're just starting to talk about these tokens, but it's really seeming like something that is gaining momentum, and each one is doing it differently, because you have those doing script, there's those who are tokenizing, there are several companies and several projects, each one doing it in a different way. And honestly, I believe this is a really such an interesting topic, and the possibilities that are opening up are really, the sky is the limit. With 2 or 3 hours, we would never have enough for this, because of what we really should cover. But I don't want to take more time. I know that, I mean, this is being recorded, and then we will be able to broadcast this video so that those people who couldn't join live this webinar can watch it later. And I don't want to take too much time, because I know that this has been very long, but I want to thank you before we conclude, and try to maybe have another meeting at some point, or some other webinar, because we would really like to hear from you more in detail. So maybe arrange for some other time where we can really, you know, describe this wide range of possibilities that is opening up on this
Sure.
topic. It's like endless.
Okay. Yeah, we can do that.
Bueno, María Eugenia.
Okay, Maria Eugenia. I guess that's a wrap.
Great. Well, thank you very, very much for having me.
Just thank you all once again. Thank Miguel, thank Eva, thank you, Christina, thank you, Ramon, and thank you, Ramon from BSV Valencia. Thank you, Brendan. Thank you, Jack. Thank you, Mika from Enchain. These were really 3 marvelous presentations. I learned a lot, and I hope you all learned as much as I did. And thank you, Ramon, again. The best co-host ever. The only one I've had, but the best anyway. Thank you. And we will see if we can organize another webinar soon. Thank you very much all for coming.